This video is going to talk about permutations and combinations, a unit that we're learning here in Pre-Calculus 30, and it's going to zero in specifically on this. You'll need this handout to complete this lesson. Lesson 4, formulas of permutations and combinations. You can find this either handed out to you right now or go to puremath30.com and you can find it there as well. We're going to be looking now at permutations, where we talked about that means order is important in the arrangements we're looking at, and combinations where order doesn't matter. We've been relying heavily right now on our calculator to help us through actually crunching the numbers and what these values would be. But this lesson today jumps in and actually starts looking at the permutations and combination formulas. These are found on your formula sheet for the course, so there's no need to actually burn these into your memory. They're here. All you need to know is that both a permutation formula and the combination formula rely heavily on your understanding of factorials. Okay, and we'll look through these examples on what that actually means. So we'll just jump in and start looking at this first example that says expand and simplify 6p2 without using a calculator, which means use the formula. So 6p2, if we were to consider this, this would be our n, this would be our r, and to start with the formula, it's n factorial over n minus r factorial, just from above there. Now just substitute the values in that we need. So n factorial, that's 6 factorial, over 6 minus 2 factorial. We can clean the denominator here. That's 6 factorial over 4 factorial. Now a lot of people would be tempted to run to their calculator right now, figure out what 6 factorial is, figure out what 4 factorial is, and divide them. We're going to look at this in a purely algebraic way. We're going to look at 6 factorial meaning 6 times 5 times 4 times 3 times 2 times 1, and 4 factorial being 4 times 3 times 2 times 1. And if we examine what we wrote there, the numerator and the denominator has a sequence or a series of multiplications that are exactly the same. This and this would divide out to 1, simply leaving me with 6 times 5. So 6p2 is 30. Without using a calculator, we figured it out. So let's look at the next example now. The next example is saying, let's expand and simplify 7c5 without using the calculator. So 7c5. I'm going to start by writing down what this is. This is the formula from up above, or our formula sheet. Substitute in the values we need. So over here, this is my n, this is my r. So it's going to be 7 factorial over 5 factorial, and then 7 minus 5 factorial. We can clean this up a little bit. 7 factorial over 5 factorial, 2 factorial. We could use our calculator to figure out all these factorials, or we could look at the whole concept of a factorial and realize the numerator, 7 times 6 times 5, 4, 3, 2, 1, all over top of 5, 4, 3, 2, 1, and 2 factorial is 2 times 1. Again, if we examine it, our numerator and denominator have the same sequence of multiplication. 5, 4, 3, 2, 1 divides out with 5, 4, 3, 2, 1, which leaves us with 7 times 6 on the top, which is 42, 2 times 1 in the denominator over 2. So that means 7 choose 5 equals 21 just using the formula. So you can see the formulas aren't complicated. A lot of stuff kind of works out and helps us to make the calculations a little smaller. So we're going to jump to the next page, and we're going to look at this maybe in a little bit faster light. It's saying expand 7p3 by canceling factorials. We're going to look 7p3. We're new at using these equations, so I'm going to write down the formula again. N factorial over n minus r factorial. Same kind of question we've just done. We're going to substitute this in. 7 factorial over 7 minus 3 factorial. which would give us 7 factorial over 4 factorial. We can use the same idea we just used in the last page there to calculate these numbers, but it says calculate by canceling factorials, which actually makes it a little easier. Start with the larger factorial. So in this case, the numerator has a 7 in there. Start with that and start counting down until you reach the 4 factorial. So the top would be 7 times 6 times 5 times 4, and it would keep going, but I'm going to stop at 4 factorial because my denominator also has 4 factorial. And if I look, 4 factorial divided by 4 factorial, those cancel, and this leaves us just to go 7 times 6 times 5, which is 210. So canceling factorials actually makes this exercise a little bit easier. We don't have to write out all that work. We can stop when 1 factorial on in the numerator is the same as the denominator, and we can cancel it out. Now, in pre-calculus 30, we have to be able to do this in general terms as well. General terms meaning there's no specific number like a 7 factorial or a 4 factorial, but now we're actually working with this expression here. It says simplify this expression. N plus 2 factorial divided by n minus 1 factorial. To do this, look at the factorials, the numerator and the denominator, and determine which one actually would represent a larger number. N plus 2 would be larger than n minus 1. So we're going to start in the numerator in this case and count down until we get to that n minus 1. So if I was to look at this, I'm going to leave the bottom, n minus 1 factorial. I'm going to start at the top and start counting down till I get to n minus 1 factorial. So remember, factorial starts with the number, and we start counting down. N plus 2 is first. 1 less than that is n plus 1. 1 less than that is n, or n plus 0. And 1 less than that is n minus 1. There we stop, and that factorial is still there. So if we look, those two can come off, and my answer simply to this would be n plus 2 factorial divided by n minus 1 factorial is the same thing as n plus 2, n plus 1, all multiplied by n. And you could go and actually FOIL those first two, distribute in the n, and get a cubic function, but for the sake of this, we just know that this simplified down to this one expression. The next example, simplify this expression, 2n plus 1 factorial over 2n plus 3 factorial. Again, identify which is bigger, the numerator or the denominator. In this case, 2n plus 3 is larger than 2n plus 1. So we'll leave the smaller one, 2n plus 1, in the numerator. We're going to start with the bigger one in the denominator this time and count down until we reach that same factorial on the top. So it's 2n plus 3. We keep counting down. The next one, 2n plus 2. And after that, 2n plus 1. That's the factorials. They're the same top and bottom. So they divide out. Remember, when they divide out, it actually leaves us with a 1 on top, and the bottom, 2n plus 3 times 2n plus 2. This is the simplified expression. No more factorials. We cancel some stuff out. Again, you could FOIL that denominator, but in this case, it doesn't make any difference. Example number 4, identify the larger factorial first. N minus 3, n minus 4. Hopefully you can identify that n minus 3 is actually larger than n minus 4. So we're going to start with the numerator in this case. Keep the denominator because it's smaller. Just keep it that way. Start with the numerator, n minus 3. 1 less than that, n minus 4. That's a factorial. It's the same on the top and the bottom, so these things divide out to 1. This whole expression then simplifies to just n minus 3, final answer. The last example on this page is saying simplify this expression, n plus 2 factorial all over n plus 2. Now, you have to be aware that these are entirely different. This guy does not, the denominator, sorry, does not have a factorial with it where the top does. So I simply can't just say these are gone and I'm left with that. That doesn't work out at all. The factorial sign cannot exist without some kind of number in front of it. So here we're going to start with the factorial and we're just going to start counting down. So the bottom I'm going to keep the same. It's n plus 2. The top starts at n plus 2 and I can count down to n plus 1 factorial. This is a case now where my factorials are not actually canceling out on one another. The n plus 2's divide out to 1. And this answer, this thing would simplify to simply n plus 1 factorial. So we're just working with the expressions, working with the formulas, simplifying it down. Here's an important thing to look. 0 factorial always equals 1. It's one of those things you just have to memorize, burn to your memory. You can go online and Google why that happens. There's some pretty long explanations as to why that you may be interested in. You may not really at this point care. So this is something you just have to remember, because in calculations, this would come into play. So just remember that 0 factorial is equal to 1. So right now, after this, I'm going to suggest that you work through these questions here, simplifying them. The answers are there provided. And go back a page again, or 2 pages, sorry, and do the questions at the bottom of that page as well. So work through those simplifications using the formula, not using the formula, canceling factorials, and we'll move on to the next lesson here shortly.